Genetics based problem 12. There is a statement about this problem that male pattern baldness is recessive and X-linked. So we have to concentrate on the statement that this disease, which is baldness, is recessive and X-linked, which is present on the X chromosome. A woman who has a father with same disease, that is male pattern baldness, she marries with a man who also has this disease. So a woman who marries to a person, the person has this disease as well as the father of the woman also has this disease. And this disease is recessive X-linked. So we have to find out the probability that any son which is born to this female, what would be the probability of the baldness in those sons which will take birth to this woman. So based on the information provided, we have to see if the disease is X-linked and it is autosomal recessive, what would be the genotypes and what would be the phenotypes. So here, that if the female is normal, then the genotype would be both the alleles would be dominant. B is for dominant, capital B is for dominant, while small b is for recessive allele. So female would have both dominant alleles. On the other hand, she has one dominant allele, one recessive allele. So she can be with both X chromosome having dominant alleles and with either of the sex chromosome, one with dominant allele and one with recessive allele. So in both cases, female would be the normal. While in case if she has both recessive alleles, a recessive allele on one X chromosome and recessive allele on the other X chromosome, then she would have baldness. While in case of males, because male they have one X chromosome and one Y chromosome, so if there is dominant allele on X chromosome, then the male would be normal, while if the male has recessive allele on the X chromosome, then the male would have baldness. So these are the phenotypes and genotypes based on the information provided in the statement. So in this case, the male would be X with recessive allele and Y chromosome, because the male have the disease, that is baldness. The woman has at least one recessive allele from her father, and the homozygous recessive condition is rare. Therefore, she would be heterozygous because she has two chromosomes, chromosome X1 and the second X chromosome. Because she is normal, so she has one dominant allele and she has second recessive allele. So in this case, female is heterozygous. She has one dominant allele, one recessive allele, and the male, because he has just one X chromosome and there is recessive allele, due to recessive allele, the male is with baldness. So if we draw the Punnett square, in this case, this is the alleles or the gametes of the male and these are the gametes of the female. So in this case, there will be birth of two sons. So these are the two sons. One son will be with dominant allele, this one, and the second son will be with recessive allele, because capital B was for dominant allele and small b was for recessive allele. So there will be the birth of two sons as a result of Punnett square. And if we see that out of two sons, one of the son would be with baldness. So we can say that there are two sons and one of the son will be with baldness. So this is the son that would have baldness. So we will say that 50% of the son would be with baldness. So as a result of this statement, we can conclude that 50% of the sons would be with baldness.